Question 1, indices. So another indice question, I want to write everything as the same base. So here 2 would be the easiest base to use. And 4 is the same as 2 squared. And 2 times root 2 is the same as 2 to the 1 times 2 to the half. Add the powers together gives me 2 to the 3 over 2. And because it's the reciprocal of that, 1 over, it means we have 2 to the negative 3 over 2. So this is equal to 2 to the negative 3 over 2. Okay, I can write this as 2 to the 2y, because when we multiply the powers when they're bracketed like that. And now everything is in terms of 2. Oh, actually, first off, let's add these two together, because we're multiplying the 2's, so we add the powers. Perfect. And now we've got 2 to the something equals 2 to the something, so those somethings must be the same. So x plus 2y must equal minus 3 over 2. And it asks us for y as a function of x, so we need to make y the subject. So we minus the x over, and then we divide by 2. Like so. We might want to tidy that up because we don't like having a fraction in a fraction. So what we could do is times top and bottom by 2, which gives me this. I think that looks much neater. Lovely. Question number 5, we need to complete the square. So I'm going to take out a factor of 2, write x squared plus 2x, and then plus 9. I'm then going to complete the square here, which is going to give me x plus 1 all squared minus 1 squared plus 9. Which is going to give me 2 lots of x plus 1 all squared. 2 times minus 1 is minus 2, and then plus 9 is going to give me plus 7. Perfect. Next I'm asked to sketch the curve. So I'm just going to draw a quick axis here. And the first thing I can spot is that it's going to have a y-intercept of plus 9. So I'll draw that there. The turning point will be where x is equal to minus 1. That will make this bracket here 0. And that will leave y is equal to 7. So I'll draw the turning point there, minus 1, 7. And that's it. Just draw a quadratic that goes through these points. Great. Okay, next. That's part B. Let's move on to part C. This is where it gets tricky. Describe fully the transformation that maps the curve with that equation onto the curve y is equal to g of x. Now you could do this by literally drawing these two on your calculator, the original one and then this one, and solving and finding where the minimum point is and then showing the translation. But what I'm going to do is I'm going to do it algebraically, and I'm going to spot that here we've got an x minus 2 has been subbed in, but here we don't. But this can be rearranged so that we do. So I can write g of x is equal to 2 lots of x minus 2 squared plus x minus 2, but there are 4 x's there, so I'm going to have to do 4 times x minus 2. And if I were to do that, then that would be the same as x minus 2 minus 8. But I want it to be minus 3 in total, so I'm going to need to add 5. And that will give me the same function as up here. And now all the x's have been replaced with x minus 2's, So that means a translation by the vector. So x minus 2 means 2 to the right, so 2 to the right. And before, we had a y-intercept of 9. And here we're going to have a y-intercept of 5, so it means it's gone down by 4. So minus 4. So that is the translation. Again, what you could do is you could just sketch this on your calculator, solve for the minimum point, and then work out what the translation is. Okay, find the range of h of x. Well, h of x is 21 over the completed square that we had here. Now, the completed square has a minimum value of 7, as we can see from the graph there. So that's the smallest it could be. So that's what I'm going to try first. So when x equals 7, we get h of x is equal to 21 over 7, which is equal to 3. And then every other value that comes out of this completed square is going to be greater than 7. So let's try and sub in a larger number. So let's try and sub in, for example, 100 and see where we get to. So 21 over 2 lots of 100 plus 1 squared plus 7. Okay, so that implies that we are tending to 0 because that's a very small number. And what we could do is we can then change it to maybe 10,000. And you can see here, again, tending to 0, becoming very, very small. So the range of h of x is it's between 0, but not equal to 0, and 3, because it can equal 3. Okay, this is a modelling question using straight lines. Lots of text. Don't enjoy these types of questions. On any day, the total cost of the factory, y pounds of making x bars of soap is modelled to be the sum of 2 separate elements. A fixed cost, a cost that is proportional to the number of bars of soap that are made on that day. Write down any general equation linking y with x for this model. Okay, so the total cost, y, is equal to a fixed cost, let's call that C, plus a cost which is proportional to the number of bars of soap. So as x increases, this cost increases as well, so it's k multiplied by x, where k is the constant proportionality between the overall cost and the number of bars of soap that are made. The bars of soap are sold for £2 each. On a day when 800 bars of soap are made and sold, the factory makes this profit. On a day when 300 are made and sold, the factory makes a loss of this. Using the above information, show that y is equal to blah blah blah. Okay. Okay, it's quite difficult to get your head around this, but let's just work through it. And we know that when 800 bars, so 800, we sell them for £2 each. So this is how much money we make. Well, this is how much money we get in revenue, and the profit is 500. So how much of this must be cost? Well, it must be 1100 in order to allow £500 of profit. So y is equal to 1100 when x is equal to 800. And if we have 300 bars times by 2, that's £600. and we make a loss of £80. So how much cost would there have been? There must have been 680 cost in order for us to make a loss when we only return 600. And that happens when x equals 300. Okay, so we've got essentially two pairs of coordinates, so we can form a straight line. So the gradient, which is k in this case, is the change in the y, so 110 minus 680, over the change in the x, which is 800 minus 300. So we put that into our calculator, and we divide that by 500 on the bottom. So great, we get k is equal to 0.84. And then in order to find c, we would just do y, we would just sub in, let's sub in 1100 is y, k is this, x is this, so plus c. Let's rearrange to find c by doing 1100 minus 0.84 times 800, and we get 428. Okay, perfect. So that's it, and then it just says show that, so I'll just put it all together. There we go. Okay, with reference to the model, interpret the significance of the value of 0.84. Okay, well, we were told before that there was a fixed cost, so that's the constant c, and we were told that it was proportional, there was a cost that's proportional to the number of bars of soap, which is k. So that means this is the cost of making 1 bar of soap. Well, actually, it's the cost of making 1 extra bar of soap. It's probably a bit more correct. Yeah. Okay, and then next, assuming that each bar of soap is sold on the day it's made, find the least number of bars of soap that must be made on any given day for the factory to make a profit on that day. So what we would need for that is we would need that the revenue, which is 2 times the number of bars of soap, because remember that's how much they cost, that's how much we sell them for, that needs to be greater than the cost, which is 0.48x plus 428. Okay, it's just solving this equation. It's going to give me 1.16x is greater than 428. So x needs to be greater than, let's divide this, 368.9. So the answer is that x is equal to 369 for the least number of bars they need to make. Question 13, we've got a cylinder and a hemisphere, and it says the manufacturer produces a storage tank. The tank is modelled in the shape of a hollow cylinder. Yeah, blah 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 blah, blah blah blah, blah 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 blah, blah 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 blah. The volume of the finding, something useful. The volume of the tank is 6 meters cubed. Show that according to the model, the surface area of the tank in meters squared is given by. Okay, surface area. Well, the surface area of the hemisphere on top, let's call that part A, is going to be 4 pi r squared divided by 2. So that's 2 pi r squared. And the curved surface area of the cylinder is going to be 2 pi r, which is the circumference around, multiplied by the height. Okay, great. And I assume we also need the base as well. Let's call that C, and that's just a circle, so that's pi r squared. Okay. We also know the volume of the tank is 6 meters squared, so we're going to use that as well. So let me just get an expression for the total surface area first. Add these two together gives me 3 pi r squared plus 2 pi r times h. So we need to remove the h. So we use the volume information. So the volume is equal to the volume of the cylinder, which will be base area times by height, plus the volume of the hemisphere, which is half of 4/3, so 2/3 pi r cubed. Okay, great, and we're told that the volume is equal to 6. So what we'll do next is we will make h the subject by rearranging this. So we're going to get 6 minus 2/3 pi r cubed is equal to pi r squared h. We're going to divide by pi r squared to get 6 over pi r squared, and then minus 2/3 r. Okay, so now we've got h in terms of r. We can sub that in over here. So I will do that here, and we'll get 3 pi r squared plus 2 pi r multiplied by 6 pi r squared minus 2/3 r. That is horrendous. Okay, so let's simplify that, and I will do that. Let me get some more space. That's better. Okay, right, 3r squared, multiply this out, is going to give me 12. Pi's will cancel, it'll be an r on the bottom, and then multiply this through, and we'll get a 2 times 2, which will be a 4 on top. There'll also be a pi on top, and there'll be an r times an r, which is an r squared, and that will just be over 3. Okay, so how many pi r squares do we have? We have 3 minus 4/3, which gives me 5/3. So great, we get 12 over r plus 5/3 pi r squared. And that is QED. Right, part B. It says, use calculus to find the radius of the tank for which the surface is a minimum. So that means we need to differentiate this surface area with respect to r. So we get the derivative of a with respect to r is equal to, this is 12r to the minus 1 to the minus 1. And when I differentiate that, I get minus 12r to the minus 2. And then when I differentiate 5 over 3 pi r squared, I get 10 over 3 pi r. And I need to set that equal to 0. And the first thing I would do will be multiply through by r squared, which gives me just minus 12. Plus 10 over 3 pi r cubed equals 0. So solving for r cubed, will be positive 12 divided by 10 over 3 pi. So it'll be 12, and then I'll divide that by 10 pi over 3, and that will be my value for r cubed, and then I will cube root that, and I'll get an r value of 1.046. Okay, great. And then it asks me to calculate this minimum surface area, giving your answer to the nearest integer. So I just need to sub that back into the area formula. And the area formula is this one here. So I'll just sub that in, and I'll write 12 over 1.046 plus 5 over 3 pi 1.046 squared. And for the sake of the video, I'm not going to bother working that out. I'm just going to say the answer is 17.20, which gives me 17 to the nearest integer, meters squared. Don't forget your units. Lovely. Okay, here we have an exponential modelling question. A cup of hot tea is placed on a table, blah, 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 blah. That feature is the temperature. Modelled by that equation, A is constant. The temperature of the tea was 75 when the cup was placed on the table, so that means when t is equal to 0. Find a complete equation for the model. Okay, so we get 75 is equal to 25 plus a e to the 0. So that tells me that a must equal 50. And you need the complete equation, so you must write it as theta is equal to 25 plus 50 e to the minus 0.03 t to get the marks. Use this model to find the time taken for the t to cool from 75 to 60, given your answer in minutes. So what we'll do is we will set theta equal to 60. So we will take 60 and we will subtract 25, and then we divide by 50. So we get 0.7 is equal to e to the minus 0.03 t. Take ln of both sides. And that will give me minus 0.35 is equal to minus 0.03 t. So then we divide that by minus 0.03. And we get 11.9. Perfect. Okay, part C. 2 hours after the cup was placed on the table, the temperature of the tea was measured at 20.3. Use this information, evaluate the model, explaining your reasoning. Okay, well, let's see. When t is equal to 120, because I believe it is in minutes, and that's 2 hours, yep. Then the theta value we should get is 25 plus 50 e to the minus 0.03 times 120. That can go in our calculator. Whoops, wrong button. And we get 26.4. So theta equals 26.4. And if I just do a quick percentage error, I know this is only for 1 mark, so this might be a bit of overkill, but yeah, that's a big percentage error, so that's 29% off That's no good. Not good at this time period. Okay, use proof by contradiction to show there are no positive integer solutions to the statement x squared minus y squared equals 1. So with all proof by contradictions, we assume the opposite. So we say assume there are positive integers x, y such that x squared minus y squared equals 1. First thing we would do would be to difference of two squares. And now we can say that, well, x plus y, seeing as we know that x and y are positive integers, then x plus y is definitely an integer. And also x minus y will also be an integer. And how can we have two integers, 1 and 2, multiply to make 1? Well, the only way you can have two integers times together to make 1 is if they're both 1. So that means x minus y equals 1 and x plus y equals 1, which we can solve to get 2x equals 2, so x equals 1, and then subbing that back into any of these gives me 1 plus y is equal to 1, so y is equal to 0, which is a contradiction, as y, or as 0 is not a positive integer, is not a positive integer. And then we have to write a conclusion statement. Therefore, there are no positive integer solutions. Perfect. Okay, sketch the graph with that equation. Could easily use my calculator here, but I'm not going to. What I'll do is I'll sketch a graph which has a negative intercept, -5, and it has a gradient of 2, so therefore it will go through here at 2.5. But because it's a modulus, it will be reflected in the, will be flipped up like this, which means that goes through 5, and we can get rid of this part. And that is good. Part B, find the values which satisfy this. So just by looking here, it looks like we're going to get a negative and a positive. So we will write out the modulus equal to 7, and then we'll do it multiplied through by negative, so that swaps the signs over like that. This gives me 2x is equal to 12, so x equals 6. And this gives me minus 2x is equal to 2, so x is equal to -1. Find the values which satisfy this inequality. Okay, we will do the same thing, but first off I'll just sketch it. So we've got a negative intercept, and we've got a gradient of 1x. So it looks like we're going to do that. Let's draw that maybe a little bit clearer. Something like that. Okay, so let's find the two places where they intersect. So that gives me 1x is equal to 2.5, and over here we will get 3x 7.5. So x is equal to 2.5. Holy moly. What does that mean? Well, what that means is the line goes like this. Okay, which means that the red graph is always on top of the purple graph, apart from at this one point where they're equal. So that means you could write that in set notation by saying that x is less than 2.5 or x is greater than 2.5. Or there's another way of writing it. You could write x is a real number such that x does not equal 2.5. So that just means that it's every number other than 2.5. Beautiful. Show by using algebra that the sum of the integers between 1 and 600 inclusive that are not divisible by 3 is 120,000. Okay, so what we can do is we can first work out all of the sum of all of them. So the sum up to 600, if I'm counting all the numbers, will be 600 over 2 multiplied by 2 times by the first number 1 plus 600 minus 1 times by the difference of 1. So this is going to be 300 times by 2 plus 599. So this is going to equal 300 times by 601. And we get 180,300. So these were all the integers in total, and the next one I'm going to work out is all the multiples of 3. So I'm going to sum up 200 terms because there are 200 multiples of 3 up to 600. So that'll be 200 over 2. The first term will be 3, so 2 times 3, plus, again, 200 minus 1 is n minus 1, and the common difference between the terms is 3. Okay, so this is 100 multiplied by 6 plus 199 times 3, which is 597. And then if I add 6 to it and then multiply it by 100, I will get 60,300. And I need to subtract because we're looking for all the numbers which are not divisible by 3, so I'm going to take all the numbers and divide and minus the ones which are divisible by 3. And when I subtract, I get 120,000. Question number 3, we've got this, what looks like a periodic sequence, and I'm going to use a little bit of a cheat code. I'm going to go to the recursion button on my calculator, and I'm going to type in this formula, which is an minus 3 over an minus 2. I'm going to set, let's do the first 6 terms, let's set a naught equal to 3, and let's execute. Great. So we get a1 is equal to 3, a2 is equal to 0, a3 is equal to 1.5, A4 is equal to 3. Okay, great. So now we can spot that this is a period of 3. So for every 3 we get a total of 4.5. So let's times that set of 3. I want to get as close to 100 as possible. So let's times it by 33. That gives me 99 terms. And then this period is reset. So the 100th term will be at the start, which will be 3. So that's all I need to do is just 4.5 times 33 plus 3, get 151.5. Brilliant, that's part A. Part B, right, so I've already got that one there, and now I need to add on up to 99, which is just 4.5 times 33. So just add on 4.5 times 33, and job's a good un. Some beastly binomial. Use binomial expansions to show that this horrible thing is equivalent to this nice expansion. Okay. Well, this is the same as 1 plus 4x over, to the power of a half over 1 minus x to the power of a half, which is equal to 1 plus 4x to the power of a half times 1 minus x to the power of minus a half. Okay, let's do that then. Let's do each one separately and then multiply them together. So luckily we don't have to take out any factors here because these are both 1. Yeah, the constant term is both 1. So just using the formula, for the first one we get 1 plus nx, so the power times by the x, so that's a half times 4x, that's 2x. And then we have 1/2, drop the power down by 1, so minus a half, all divided by 2 factorial, which is 2, multiplied by 4 to the power 2. Okay, so this is equal to 1 plus 2x. This is going to give me a negative. We're going to have an 8 on the bottom, but we're going to have 16 come out of here, so that's just 2, and that's x squared. Okay, let's do it for this one here now. We're going to get 1 again. The first term is going to be the power multiplied by the x, so 2 minuses will cancel out, we'll get a half x. And then the next term will be the power, drop it down by 1, all over 2 factorial, which is 2, and then minus x to the power 2. Okay, so what will this give us? We'll get an 8 from the bottom again. We'll get 2 negative make a positive and a 3 on top. And we'll also get that will turn positive because you're squaring it, so that's just x squared. Okay. So next what we need to do is multiply these two together. Like so. But we only need to get terms which are going to give us less than or equal to x squared. So we'll do 1 times 1 is 1. We'll do 1 times a half x. And we'll do 1 times 3 over 8x squared. We'll do 2x times 1. We'll do 2x times a half x, which is x squared. We won't do 2x times 3 over 8x squared. We will do minus 2x squared times by 1, but we won't do minus 2x squared times by anything else. Okay, let's simplify. We have a half x and 2x is 5 over 2x. And we have 3 over 8x squared minus an x squared, so that's minus 5 over 8x squared. And that is as required. A student substitutes x is equal to a half into both sides of the approximation shown in part A in an attempt to find root 6. Give a reason why the student should not use a half. Well, if we look at this one, that's only valid when 4 over x modulus is less than 1. So that means when x is less than or equal to a quarter. So x equals a half is not valid. The student substitutes x equals 1 over 11 into this to attain an approximation of root 6. Oh, why do I, sorry, yeah, let's just substitute that in and then obtain root 6. Okay. So we'll sub it into both sides, and let's just do that on my calculator here. So I'm going to do 1 over 11, execute, and then I'm going to do the square root of fraction 1 plus 4 lots of the answer over 1 minus the answer. Okay, that gives me root 6 over 2. And that is equivalent to subbing it into the expansion. So I'll do that by doing 1 plus, oh no, I need to do 1 over 11 again. Execute, and then 1 plus 5 over 2 times by the answer minus 5 over 8 times by the answer squared. Okay, that gives me 1183 over 968. So we'll just multiply both sides by 2. And it gives me 1183 over 484. Brilliant. Okay, getting tricky with it. Here we go. Cos 2 theta could be transformed into many things, so I'm actually going to start over this side. So tan theta sine 2 theta is the same as sine over cos is tan, and that's times by 2 sine theta cos theta, because that's the double angle formula for sine 2 theta. Okay, this is, we're going to get cos theta cancelling, so I'm going to get 2 sine squared theta. Okay, and that tells me which one to use. I'm going to use the one which uses sine squared, and that is 1 minus 2 sine squared theta. When multiplying out, I get 1 minus 1, which is 0, and I just get minus times a minus is a plus, so I get 2 sine theta. So this was the right hand side, this was the left hand side, and I can write right hand side equivalent to left hand side QED. Right, hence solve for this range. The equation sec squared minus 5 1 minus cos 2 theta is equivalent to tan squared 3 tan squared sine 2 theta. Okay, so I suspect I will need to replace this with this. Let's do that. So sec squared x minus 5 is now multiplied by tan theta sine 2 theta, or tan x, sorry, sine 2x, and that's equivalent to 3 tan squared x sine 2x. Okay, we can remove the sec squared by replacing it with the identity, which is sec squared x is equal to 1 plus tan squared x. So this becomes tan squared x plus 1 minus 5 is minus 4, multiplied by tan x sine 2x, and that's equal to 3 tan squared x sine 2x. Okay. Next, we can divide through by sine 2x, but in doing so, we must be wary and know that this is a solution equal to 0. And we can solve that now. So when I take sine to the minus 1 of 0, I get 0. And the next time that sine is 0 is at pi, or minus pi, going back the other way. But when I divide it by 2, they'll be out of the range because they're not equal to minus pi over 2 or pi over 2. So in fact, x equals 0 is the only solution that comes from that. Okay, next, multiplying out these brackets gives me tan cubed x minus 4 tan x is equal to 3 tan squared x. And we can divide through by tan, which gives me this. But once again, if I divide through by something like that, I need to check to make sure we haven't lost a solution. And this gives me x equals 0, and the next one along will be pi, but again that's out of the range, so it just gives me that solution again. So now this is a quadratic essentially, so I can replace it with a y. Sometimes that helps people factorize and whatnot. So when I factorize this, I will end up with minus 4 and plus 1. So this gives me that tan x is equal to 4 and tan x is equal to minus 1. Okay, so we will go to our calculator for this. We will do shift tan of 4, and we get 1.32. And if we were to add pi to that, then that's going to be out of the range for sure. If we were going to take away pi to that, again, that will be out of the range as well. We could just check that. And if I were to add on pi over 2, I wouldn't get back to 0 yet, so that's out of the range. And finally, let's do shift tan of minus 1, and we get minus pi over 4. And again, if I were to add pi to that, I would get 3/4 pi, which is out of the range as well. So it looks like we've got 3 answers along with x equals 0. Question 13, have you ever seen a more iconic duo, EDEXCEL A-level paper and a Ferris wheel? I don't think so. Okay, our cos. So straight away I know that my A value is 10 because that's the one next to the cos, and we're doing our cos, which means our B value is 3. Okay, so A is 10, B is 3. That's all I need to know. A is 10, B is 3. That means R is the square root of 10 squared plus 3 squared, which is equal to the square root of 109. And alpha is equal to tan to the minus 1 of B over A. Just double check radians or degrees. Degrees. Interesting. So we do shift setup degrees, and then we do shift tan 0.3, and we get 16.7. Great. So we can say that is root 109 cos of theta plus 16.7. Easy peasy marks. It does say 2 decimal places. Whoopsie. Okay, now we have this Ferris wheel, and we've got this, and that's very similar to what we've got here, but theta is just swapped out for ATT. And then we also have an A. Oh, and it's also minus. So it's going to be A minus root 109 cos of ATT plus 16.70. Okay, it says that the graph of h against t for 2 complete cycles of the wheel, given that the initial height of the passenger above the ground is 1 meter, find a complete equation for the model. Okay, so initial height means that t equals 0. So we have t equals 0, which gives me a minus root 109 cos of t is 0, so just 16.7. And we're told that's equal to 1 meter. So we can solve for a by doing 1 plus the square root of 109 multiplied by cosine of the previous answer, and we get 11. Okay, so that means A is 11, sorry. And that means my complete model is h is equal to 11 minus root 109 cosine of ATT plus 16.7. And then the next part says find the maximum height of the passenger above the ground. So the maximum height will come when the cosine is equal to -1. Because that way, when you times it by minus root 109, you get the biggest possible value. So h max is equal to 11 plus root 109, and that is 21.44 meters. Okay, part C. Find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. Okay, so yeah, it's the second one. Right. So we know that the maximum occurs when the cos function is equal to -1. So doing cos to the -1 of -1 gives me 180. Yep, that makes sense. So we get 80t plus 16.7 is equal to 180. Now, what's the next time that the cos graph hits -1? Well, we've got to add 360 to that, so that's 540. And seeing as the first one is not what we're looking for, it's going to be the second one. Okay, so let's just rearrange this formula for t. 540 minus 16.7 divided by 80, 6.54. And what does it want it in? To the nearest second. Okay, so that's minutes. So we've got 0.54 of a minute, so times that by 16, it gives me 32 seconds. Okay, great. It is decided that to increase profits, the speed of the wheel is to be increased. Ooh. How would you adapt the equation of the model to reflect this increase in speed? Okay, well, what we want is we want it to go like this, much quicker. Which means that graph transformation wise, it's going to be a compression in the x-axis. So that means what we need to do is multiply the input by a higher number. So we'll need to change the 80, we need to increase the 80 basically. Yeah, increase the 80 in the formula. And we're done. Implicit differentiation, question 9, it says there's the curve and it says find dy by dx. Okay, so I've got to differentiate this implicitly. And this is going to give me 2x. And this is a product, so I will differentiate the 2x part first to get 2, and I'll leave the y alone. And then I will leave the minus 2x alone, and I'll differentiate the y to get dy by dx. And when I differentiate this function with respect to y, I get 6y, but because I'm differentiating with respect to x, I need to multiply it by dy by dx. And that equals 0. Okay, I will pick up all of the non-dy by dx terms, move them to the other side, and I'll also factorise out a dy by dx of what's left. So dy by dx, we have a 6y and a minus 2x, and then these are going to go to the other side to get 2y positive and 2x negative. We're then going to divide through by that factor to get 2y minus x over 6y minus 2x. Oops, sorry, 2x. Top and bottom divide through by 2, and Bob's your uncle, there it is. Okay, now it says that the curve is modelled by the shape of the cycle track, yeah, blah blah blah. P and Q are the furthest west and east. It says using part A, find the exact coordinates of point P. Now point P has a vertical tangent, which means the gradient there is infinite. And the way we find that is by taking the derivative's denominator and setting it equal to 0. So at that particular point, the gradients denominator is equal to 0. So 3y minus x is equal to 0. So 3y is equal to x. And also at that particular point, it's on the curve, which means it satisfies this equation. So let's sub in what we've just learnt into that equation. So I'm going to replace the x's with 3y's. So it starts off x squared, so that's going to become 3y all squared. We then have minus 2x times y, so minus 2 times 3x times y. And we've got plus 3y squared is equal to 50. Okay, this gives me 9y squared. This gives me minus 6y squared plus 3y squared is equal to 50. So this gives me 12, that gives me 6y squared is equal to 50. And that means that y squared is equal to 50 over 6. So to the calculator, we got the square root of 50 over 6, which is 5 root 3 over 3. Plus or minus, should I say. Okay. Quick inspection. I can see that the point I'm looking at, the y value is negative because it's below the x-axis. So the y value I'm looking for is minus 5 root 3 over 3. And what did we say the x value was equal to? X is equal to 3 times y. So times that by 3, I get minus 5 root 3. Okay, part C is to explain briefly how to find the coordinates of the point that is furthest north of the origin. You do not need to do this calculation. So the point furthest north is where we have a gradient of 0. So that means that the numerator this time will equal 0. So we will say that y is equal to x, solve with the equation, like that. And a bit like last time, we worked out, we used the negative one. When we do this, we will need to choose the positive solutions, because obviously this point up here is in the positive quadrant. We don't want to accidentally find this one down here in the negative quadrant. Okay, here we have parametric equations, and it says that they meet the circle C2 with this equation at 4 distinct points as shown. Given that one of these points lies in the fourth quadrant, 1, 2, 3, 4, find the Cartesian coordinates of S. Okay, so we need to solve simultaneously. So what we'll do is we will sub these parametrics into this circle. So we're going to get x squared, which is going to be 100 cos squared t. Y squared is going to be 16 times 2 is 32 sine squared, and that's equal to 66. Okay, next we want to get it all in terms of either cos squared or sine squared. So let's just replace the cos squared with 1 minus sine squared using our identity, classic identity. Cos squared plus sine squared equals 1. Let's expand out, which gives me 100 minus 100 sine squared t plus 32 sine squared t equals 66. So this is going to give me minus 68 sine squared t minus the 100 over to there gives me minus 34. Great, divide through by minus 68 and I get sine squared t is equal to just 1/2. and that means that sine t is equal to plus minus the square root of a half, which is a quarter. Sorry, not a quarter. What am I talking about? It's just the square root of a half, which is plus minus 1 over the square root of 2. Okay, so let's find the t values then. Well, actually, in fact, we don't need to find the t values because we can just go directly to our equations for y. So, what do we need? We need it to be in this quadrant here. So I need the y to be negative. So my sine t, which I'm going to sub into the y, must be the negative one. So my y value will be 4 times root 2 multiplied by the negative 1 over root 2. Oh, sorry, yeah, perfect. Okay, so these cancel. So we just get that y is equal to minus 4. Okay, now how are we going to work out the x-coordinate? Probably the quickest way would just be to sub it back into this. Because y is minus 4, it means y squared is going to be 16. Which means that x squared will be 50. So x will be plus or minus the square root of 50. Which is plus or minus 5 root 2. But which one do we need? Do we need the plus or the minus? Well, it's in this quadrant where the x is positive, so we need the positive one. So my overall coordinate for s is positive 5 root 2, negative 4. Question 13, we have parametric equations, and it looks like we are differentiating them. Lovely. Okay, and they're trig ones as well. How exciting. To find dy by dx, we must differentiate the y first with respect to t, and that's going to give me 2 root 3, because the 2 is going to come out of the input. Cos differentiates to minus sine, just like that, and that's over the derivative of x, which is going to be just 2, again minus sine. Okay, I'm not going to simplify it. I mean, I will simplify it just slightly, but I don't need to. So just ask me to work out dy by dx. Okay, I'm just too much of a good guy. I will simplify it even further. Sine 2t is 2 cos t sine t. So the sine t's will cancel, so it's 2 root 3 cos t. Part B. The point P lies on C where t is equal to this. The line L is normal at P. Show that the equation for the line L is this. Okay, so we're going to need a couple of things here. We're going to need the x and the y coordinates of when the t is equal to that. So we will do that. We will type in 2 pi over 3 equals, and I will do 2 cos of that, and I get minus 1. I'll then delete that line, and I will do root 3 multiplied by cos of 2 lots of the answer, and I'll get minus root 3 over 2. Okay, and then I will also need to sub it into the gradient as well. So I will press delete line and I will sub into 2 root 3 cos of the answer. And I'll get minus root 3. Okay, so the normal gradient is a negative reciprocal, so that's 1 over root 3. Right, I've got all my tools now. So the equation of a line is y minus y1, so minus minus makes plus. And then that's equal to m, which is the gradient of the normal, over x minus, the x value is minus 1, so plus 1. Okay, great. I'm going to multiply through by 2 root 3 because I can see the y is 2 root 3. So times it by 2 gets rid of the 2 on the bottom. Root 3 times root 3 is 3. The root 3 will cancel, and I'll also need to times through by 2. So I get 2x plus 2. And I want to bring it all over to the right hand side such that I get 2x minus 2 root 3y and then minus 1 as required. The line L intersects the curve C again at the point Q. Find the exact coordinates of Q. Okay, so it intersects again. So what I'm going to do is I'm going to do a simultaneous equation with the curve and the line. And the best way of me doing that is by subbing these two into here. So for part C, I get 0 is equal to 2 lots of the x, which was 2 cos t. So that makes 4 cos t. Minus 2 root 3 times by the y, which is root 3 cos 2t, minus 1. Okay, simplifying this somewhat, this gives me minus 6, and cos 2t, we should know from our double angle, is 2 cos squared t minus 1. So that's helpful because now we're all in terms of cos t. This is minus 12 cos squared t, and this is going to give me plus 6 minus 1 is plus 5. Tidying up a bit more, multiplying through by negative 1 gives me this. Going to be lazy, go to my calculator to solve this quadratic. Okay, 5 over 6, so I get cos t is equal to 5 over 6, and cos t is equal to minus 1/2. Okay, let's remind ourselves which was the one which we've just found, the point P, x equaled minus 1. So that means that 2 cos t equaled minus 1, so cos t equaled minus 1/2. So that was the point P. So I don't want that one. I want this one. This is the new point, point Q. What's the x value then? Well, we know the x value is 2 cos t. So the x value is 2 times 5 over 6. Which is 5 over 3. And then what about the y value? Okay, the y value is equal to root 3 cos 2t. So y value is equal to root 3 cos 2t, which is equal to root 3 2 cos squared t minus 1, again using the double angle formula. And we know what cos t is. It's 5 over 6. So this is what I need to put into my calculator. So we will do 5 over 6 squared, and it's not the best way of doing this, apologies. Let's do 2 lots of it. Minus 1, 7 over 18 times by root 3, so that's 7 over 18 root 3. So I believe that answers the question. Yeah, the exact coordinates of Q, 5 over 3, 7 over 18 root 3. Beautiful. Tell me that wasn't good. I don't want to hear it. Okay, question number 10, and we have a graph, and it says they're parametric equations, and it says that t has to be greater than minus 2 over 3. So state the domain of values of x for the curve. So the domain of the curve is the range of the x function. So the range of the x function, well, the smallest t value is minus 2 over 3. When I sub that in, I get x is equal to ln of 4 over 3, like that. And then when I increase the t value, it's just going to increase the x value, and that's going to carry on indefinitely. So that means that the x is going to be just greater than, so it can't actually equal this because the t value can't equal that. So x is going to be greater than ln of 4 over 3. Okay, great. Nice and simple question. Just find that area. Love it. So we need to use the formula for parametric integration, which is y dx by dt dt. And we're going to do that between ln of 4 and ln of 2. So the y is 1 over t plus 1. Oh, sorry, actually, the limits will be different. We need the limits in terms of t. So let's leave them as b and a for now. And dx by dt, well, the derivative of that is just 1 over t plus 2 dt. Need to change our limits. So x was ln 4 and ln 2. And I need to do so ln 4 is equal to ln of t plus 2, which basically means that t is 2. And ln 2 is equal to ln t plus 2, which means that t is 0. Great, so we have the integral between 2 and 0 of 1 over t plus 1 t plus 2, which means we're going to need to use partial fractions. So 1 over t plus 2, or t plus 1 t plus 2 is equal to a over t plus 1 plus b over t plus 2. Multiply across gives me 1 is equal to a t plus 2 plus b t plus 1. Let t equal minus 1 gives me just a is equal to 1, and let t equal minus 2 gives me minus b. So b is equal to minus 1. Okay, so my new integral is a 1 over t plus 1 minus b 1 over t plus 2. Fantastic. These integrate really easily to ln of t plus 1 minus ln of t plus 2 between 2 and 0. I could do ln rule and collect them up like that, because we're subtracting, so we can write it as a single ln divided. In go our limits, so we get ln of 3 over 4 minus ln of 1 over 2. And we can then do 3 over 4 over 1 over 2, which is the same as ln of 3 over 2. Yeah, dividing by the half is just the same as timesing by 2. Yeah, perfect. Okay, Newton-Raphson question, and it says that this has exactly one root. It says show that this equation, the Newton-Raphson formula, can be written like this. Okay, so let's remind ourselves what the Newton-Raphson formula is. It is xn minus the function subbing in xn over the derivative function subbing in xn. Okay, so let's do that then. So let's write xn minus, when I sub it into the function, I just get the function itself, which is 2x cubed plus x squared minus 1. And then the derivative function, well, that will be 6x squared, and it will be 2x, and that's it. Okay, now I've got to write this with this denominator, so I can subtract the 2. So I write xn multiplied through by this all over it, will then allow me to subtract these two fractions. Okay, so I've got a common denominator now, and when I multiply this out, I'm going to get 6x cubed plus 2x squared. I'm going to get a minus 2x cubed. I'm going to get a minus x squared, and I'm going to get a plus 1. And I'm pretty sure that's going to give me yeah, what I want. Perfect. Yeah, so 4x cubed plus 1x squared plus 1 over 6n squared, sorry, 6x squared plus 2x. Perfect. Right, using the formula given in part A, with x equals 1, find the values of x equals 2 and x equals 3. Okay, I'm going to get a bit techie here. I'm going to go into recursion mode, and I'm going to delete that one, and I'm going to write in the formula. So 4an cubed, should have hit a bracket first, not a bracket, a fraction, 4an cubed plus an squared plus 1 over 6 an squared plus 2an, riveting. Set, I want to start with the value of, let me just quickly check again, 1. Okay, great. So make that 1. First 6 is fine. Table. So I get 0.75 and what looks like 2/3. So x1 equals 0.75, x2 equals 2/3. Perfect. Part C, it says explain why we can't use x1 is equal to 0, and that's because we would be dividing by 0, and it's because the gradient function will have a turning point there. So there is a stationary point at x equals 0. And that's enough. We can't use the Newton-Raphson formula at a stationary point or very close to a stationary point. Question 2, it says use integration by parts to find this. Integral here. So let's do that. Let's set u equal to x and dv by dx equal to cos of a half x. Differentiate this to get du by dx is equal to 1, and integrate this. The derivative is a half, so divide by a half is the same as timesing by 2, and cos integrates to sine. Okay, great. So the integral is equal to u times v, which is 2x sine a half x, minus the integral of du by dx times v, which is just going to be 2 sine of a half x dx. Okay, so all we need to do now is just to integrate this. So a half x inside the brackets, derivative of that is a half. So dividing by a half is the same as timesing by 2, so I'm going to get 4. Sine x integrates to minus cos x, so there's going to be an extra minus there to turn that into a plus, and that will be cos of a half x plus c. Okay, next it's asking me to integrate this x squared sine a half x. So I can set u is equal to x squared, dv by dx is equal to sine of a half x, and du by dx is equal to 2x, and integrate that is going to give me minus 2 cos of a half x. So the integral which we need to calculate will be u times v, which is going to be minus 2x squared cos a half x, minus the integral of du multiplied by v, which will be minus 4x cos of a half x dx. Okay, so I can write this as minus 2x squared cos of a half x, and 2 minuses there make a plus, and I can take a 4 outside of the integral, like that. And we've already worked out this integral. That was part A. So the answer to it was this. So we can just replace that in there. So I get minus 2x squared cos of a half x, and timesing by 4 I'm going to get plus 8x sine of a half x, timesing by 4 again I'm going to get plus 16 cos of a half x plus c. Perfect. Okay, question 13, and we have a function here with some unknowns, but it says that it passes through this point and has two vertical asymptotes with the equations x equals 2 and x equals minus 3. Explain why you can deduce that q is equal to 4. Well, if it has a vertical asymptote, it means that we were dividing by 0. So that covers that part. So let's figure out this part. We know that x equals 2. So we can say that at x equals 2, 2x minus q equals 0. So that means 4 minus q equals 0. So q equals 4. Next it says show that p is equal to 15. Well, we're then going to have to use this other bit of information we're given, and that is that the x value is 3 when the y is a half. So subbing that into the equation, we're going to get a half is equal to p minus 3 times 3 over 2 times 3 minus 4, and then times by 3 plus 3, which is 6. Okay, great. So this bottom bit here is 6 minus 4, which is 2, times 6, which is 12. Times the 12 up to this side, we get 6 equals p minus 9. So therefore p is equal to 15. Great. And then part B just basically says work out that area and give your values like that. Well, if I want to integrate y here, you can see that the bottom is 2 factors, so we need to split those up and do partial fractions. So I'm going to start off by saying 15 minus 3x over 2x minus 4 x plus 3 is equivalent to a over 2x minus 4 plus b over x plus 3. Multiply through by the denominator and we get this. And then let's let x equal minus 3. 15 minus 3 times minus 3 is 24. This one cancels. Minus 3 times 2 is minus 6. Minus 4 is minus 10. So this implies that b is equal to minus 2.4. Next, let x equal 2, that's what solves that bracket. We get 9 here, and we get 2 plus 3 is 5, so 5a, and that implies that a is equal to 9 divided by 5, which is 1.8. Okay, great. So now we need to set up our integral. So we're going to be integrating 1.8 over 2x minus 4 minus 2.4 over x plus 3, and we're going to need to find our bounds. So we know here the x is 3, and here this is where y is equal to 0. So solving from the top, we had 15 minus 3x, we want the top to equal 0, and that means that x equals 5. So this right here is 5. So we're going to be integrating between 5 and 3. and this is with respect to x. And we can actually simplify this integral down a little bit, because we've got a factor of 2 on the bottom there, so we can write 0.9 over x minus 2. Okay. Now these are luns. The derivative of the bottom is just 1. So we're going to integrate this, and it's going to be ln of x minus 2. As long as we take out a factor of 0.9, then the top will be 1, which will be the derivative of x minus 2. So we're going to get 0.9 ln x minus 2. And again, here the derivative of the bottom is 1. So if I take out a 2.4, then I'm left with 1. So minus 2.4 comes out. And now I can just integrate that to ln of x plus 3. And again, this is between 5 and 3. So we're going to sub in our limits, and we're going to get 0.9 ln of 5 minus 2, which is 3, minus 2.4 ln of 8, minus 0.9 ln of 3 minus 2 is just 1, and minus 2.4 ln 6. Okay, so let's simplify. 0.9 ln 3. Ln 8 is the same as ln of 2 to the power of 3, which is the same as 3 ln 2. So this is going to give me minus 7.2 ln 2. Ln of 1 is 0. 2 minuses there make a plus, so plus 2.4 ln 6. Okay, and just a reminder that they want it in terms of ln 2 and ln 3. So this ln 6 is a bit awkward, but we can split that up, because ln 6 is equal to ln 2 plus ln 3. So we get plus 2.4 ln 2 plus 2.4 ln 3. And let's look, how many ln 3s have we got? We have 3.3 ln 3, and we have minus 4.8 ln 2. And we're done. Question 5, we've got this diagram here, and it's basically explaining that integration is an infinite collection of rectangular strips where the width tends to 0. So this notation here basically means integrate between 9 and 4 root x dx, and that's it. Okay, so to integrate, I'd want to write it as a power of x. Then I will up the power by 1 to get 3 over 2. Divide by the new power. Dividing by 3 over 2 is the same as timesing by 2 over 3. And then I'll need to sub in 9 and 4. The power of the 2 on the bottom means to root. So root 9 is 3, then cube it is 27, divide it by 3 is 9, times it by 2 is 18. 4 rooted is 2, cubed is 8, 16 over 3. This is the same as 54 over 3 minus 16 over 3. Which is equal to 38 over 3. Okay, we need to use this substitution, so integration by substitution, and I'm going to write it down here. U is equal to 4 minus root h. I don't like having square roots when I do integration by substitution, so I'm going to get rid of that. Let's make the root h positive as well by moving it over to that side, squaring both sides, and then let's differentiate with respect to u. So this gives me dh by du is equal to 2 comes down to the front, write out the bracket, drop the power, and then times by the derivative of the bracket. With respect to u, the derivative of that would be minus 1, so there'll be a minus there. Now I can make dh the subject, and we have an expression for dh. Perfect. So now let's sub back in. So we have the integral of dh was on top, which is going to be minus 8 plus u when I multiply out, over the expression on the bottom is just a substitution, so that's u. Great. We can split this up to minus 8 over u plus u over u. Oh, whoops. Apologies. Should be 2u when I multiplied out the brackets. That's plus 2 du. So this gives me minus 8 ln u when I integrate, plus 2u plus a constant c. And we need to replace the u's with 4 minus root h. So also when you ln, you should put a modulus sign around them, like that. So the modulus of, it was 4 minus root h, plus 2 lots of 4 minus root h, plus c. And we're not quite good. That's minus 2 root h there. Okay, no, not to worry. We can just multiply out that bracket and then change our constant. So when I multiply out this bracket, I do get minus 2 root h. I also get plus 8 plus c. And we can just replace this to a constant stop, call that k, where k is equal to 8 plus c. And we're good. Okay, a team of scientists is studying a species of slow-growing tree. How exciting. The rate of change in height of a tree in this species is modelled by the differential equation. Okay, so what we're going to need to do, find, according to the model, the range in heights of the species, of trees of this species. Okay, so the range in heights, well, we need to find the maximum height, and we'll do that when the derivative is equal to 0. So we need this to equal 0. Now, this part, that can't equal 0. So it's going to have to come from this part. So let's set that equal to 0. So part B, we have 4 minus root h equals 0. So that means that root h is equal to 4. So h is equal to 16. Okay, so that is the maximum height. So therefore, we can say that the range is anywhere between 0 and 16. Okay, next, it says one of these trees is 1 meter high when it's first planted. Okay, so t equals 0, h equals 1. According to the model, calculate the time this tree would take to reach a height of 12 meters, giving your answer to 3 significant figures. It's a 7-mark question, so we have to solve this differential equation. And we will do that by separation of variables. So I'm going to multiply, I'm going to divide through by the 4 minus root h on that side, and I'm going to multiply through by the dt on the other side. So I have this, and that's perfect because we already know what this left-hand side integrates to from part A. This integrates to, it was minus 8 ln 4 minus root h minus 2 root h plus k. And this integrates to, well, we could take the 1 over 20 out. And when I integrate this with respect to t, I just get the same thing. Sorry, I don't mean the same thing. I up the power to get t to the 1.25, and then I divide by the new power. And I also get, well, I don't get plus, I don't get a constant because I've already got my constant on this side. But it doesn't matter which side you put it on. Okay, next I'm going to sub in those initial conditions, which was t equals 0, h equals 1. That's going to give me minus 8 ln of h is 1, so that's ln 3, minus 2, plus a constant is equal to, and t is 0 here, so we just get 0. Okay, so that tells me that this constant k is equal to 8 ln 3 plus 2. Okay, and now the question asks us to calculate the time this tree would take to reach a height of 12 meters. So I need h to equal 12. So let's just rearrange this as best we can. And I'm going to sub in h as 12. K we said was plus ln, so 8 ln 3 plus 2. And this is the same as 1 over 20 divided by 1.25. So that's 1 over 25 t to the 0.25. Okay, I'm going to skip through this. I'm going to put that into my calculator and see what it comes out with. Okay, so I've just put that into my calculator and I've got 8.85. And as I was doing that, I realized that I didn't write that correctly. That is the power of 1.25, not 0.25. Okay, so that's good. We then multiply through by 25. Whoops. We get 221 is equal to t to the, that's 5 over 4. So to find t, I would need to raise this to the power of 4 over 5. Just reciprocal powers when you want to move it to the other side. So I'll do answer to the power of 0.8 is 4 over 5. Great, and I get t is equal to 75. And that's 0.2, and that is years.